Alright, so, year 11s. The last little thing I wanted to just look at for today. The last little thing I wanted to look at for today was one of the other ways that we can describe how steep a line is. Alright, Dylan. The other way that we can describe how steep a line is we can talk about what we call the angle of inclination. So when we talk about how steep, you will. So if we're talking about the angle of inclination, we normally talk about the angle. Girls, we normally talk about the angle when we compare it to the positive x-axis. In other words, if we compare it to this x-axis here, what is the angle that line makes with this positive axis? Now, when we're trying to talk about this is where we're going to actually bring in some of our trigonometry. So if we imagine just a straight line, and I'm not going to make it go through any particular points. What we're going to do is, let's imagine that we've got a random straight line on our graph. Elijah. If we just imagine a random straight line on our graph, we can actually create a right angled triangle in this graph fairly easily. Because if you just imagine that we draw a line by drawing a dot here and a dot here, and then we just extended this down. Then we're going to end up with a right angle. Alright, year 11s. I would really appreciate it if you stop chatting while I'm talking. This is probably about the only topic that we're going to do this afternoon that you haven't ever seen before. So it would be a shame if you don't understand this part because you're not listening. I get that this topic so far has been a lot easier than all of the other topics so far. But I'll be really honest, you need to make sure that that means that you're on top of your game for this test. Because this is your opportunity to make up for all of your previous failures. So just because it's easier, don't take your foot off the pedal. So if we take a look at this right angle here, remember that when we're talking about angles, we can start bringing in our trigonometry if we have side lengths. Now if we want to talk about the angle, we talk about theta, because you can see that the angle that this line makes with this horizontal line here is going to be the same angle that this line would make with the positive x-axis here. As you can imagine that there's another right angle here. All the angle is going to stay the same throughout. That's why we can describe this by our angle. Now if you imagine that this is the angle, and we want to fill in the other bits of our triangle and their dimensions, let's imagine this point is x1, y1. And let's imagine this point is x2, y2. If the coordinate of this point, the x-coordinate is x2, and the coordinate of this point here is x1, then this length here is going to be x2 minus x1. Because however far out this x distance is from the x-axis, from the origin, take away whatever this distance is going to be whatever's left over. So this distance here, the base of your triangle here, is going to be x2 take away x1. Similarly, the height of your triangle here is going to be y2 take away y1. Because however high this second point is, take away however high this point is, that's going to be the height of your triangle. Now we can't work out what the exact length of this part is, because we don't have any sort of information based on the coordinates that we can use to find that. You can use Pythagoras to do it, but then it ends up getting really messy. Instead, if we just use these two, can we find a relationship using our trigonometry between this side and this side? What relationship can we use? Tan. So what we've got is that the tan of theta has to equal the opposite side, which is y2 take away y1, over the adjacent side, which is x2 take away x1. Where have you seen y2 take y1 over x2 take x1 before? The gradient. So what this is really just the gradient formula. And we normally write the gradient as the letter m. So what we can actually say is that tan theta is going to equal m, where this is your gradient. And we can use this rule and this relationship to help us identify the angle of inclination if we've got the gradient, or go the other way around. If we've got the gradient, we can work out what is the angle that the object is at. So let's take a look at those two examples. Now, when we're talking about the angle of inclination, we normally talk about it with respect to the positive x-axis. So if we're trying to find the angle the line y equals 3x plus 5 makes with the positive x-axis, what we're going to do first is, let's find the gradient of this line. What's going to be the gradient of our line y equals 3x plus 5? 3. 3. It's just the number in front of the x. So m is equal to 3. Now, if m is equal to 3, that means that tan theta has to equal 3. And if we wanted to find theta, we can use our tan negative 1 of 3. Put that into your calculator. Remembering that your tan negative 1 shows up in your trig keyboard.
$71.565.
Making sure that your calculator is in degrees. 71, what was it?
0.565.
Or to the nearest degree is just going to be 72 degrees. This also works the other way around. So let's look at another example. Let's do 85 degrees. And this one's even easier. A line makes an angle of 85 degrees to the positive x-axis. Find its gradient. The gradient is m, but m is equal to tan theta, where theta is our angle. So if our angle is 85 degrees, we just put our 85 degrees in there. Tan 85 degrees is going to give me 11.43. So that tells you what the gradient has to be. Now, some of your answers for this is going to end up being negative numbers in terms of some of your angles. In terms of what a negative number means for your gradient, because we're comparing it to the positive x-axis, in other words, this line here, a negative angle just means that instead of going around this way, which is how we normally count our angle, so our angle usually works around this way, a negative angle works the other way around. So for example, this angle here would be what we consider negative 30 degrees because it's going in the opposite direction. Whereas something like this would be positive 30 degrees. Obviously your negative 30 degrees you could also measure by going all the way around, and then this would be 330 degrees. But if you show up with a negative number in terms of your answer, that's what it means. And we've seen lines that point this way before, because those are just going to be your negative gradients. So sometimes with some of your negative gradients, you might end up with a negative angle coming out as your answer. Is that a question, Jeremy?
Yeah, so if we, in the test, if we write negative 30,
yep, that's fine.
330, both right?
Both of them will be right. Your calculator will usually give it to you as a negative answer, but you can just write that in as your answer. Cool. So I'm going to add a few questions to do with this into your list of questions to do. This stuff hopefully isn't too difficult as long as you know how to use the tan and tan negative 1 function on your calculator.